lecture before break, one lecture, and then we'll have break from 11 to 11:15, and from 11:15 to 12:15 second lecture, and 12:15 to 1:15 the third lecture, right? So we'll have 3 lectures by Michael. In the afternoon, 2:50 I'll take one lecture, right? And then I'll take you to the laboratories. Then we'll try to learn how to make the nanoparticles, different methods what we are trying to do in the lab. We'll try to do the demo, and if possible, time permits, you and I try to show the efficient facility what is available in the physics department. Right. So today, this is the main schedule of the second day of this exam program. So hope you will be make use of the facilities and then attend all the lectures without fail. So if you have any numbers, try to post them so that the others come and then we can have the classes. Right? Thank you.
Nice afternoon, and you take a breakfast today, and you have some power to participate in my lecture. I hope that you not hate me after free lecture today. And now, such lecture is focused on foundation of nonlinear optics. Nonlinear optics is, in my opinion, one of subject which is most explored in India, especially South India, in Tamil Nadu. I would like dedicate my present talk to former director of Crystal Growth Center, Professor Dhanasekaran from Anna University, Chennai, which was for a long time my very good collaborator, friend, and he also showed me a different subject connected with nonlinear optics, is so-called organometallic crystals. It is also Indian specialty. Many groups growing very good quality crystals, and from time to time they obtain a material which not only possesses very good nonlinear optical properties, but also may be introduced to industry, because when you utilizing, for example, pointer which is lighting in green, it is not inside a green laser, but it is infrared laser, which radiation is transformed into different spectral range. And okay. Lecture schedule will be focused on few points. It is introduction to nonlinear optics and second harmonic generation, and the methods of creating non-center symmetry, because phenomena of nonlinear optics is strongly conjugated with a symmetry of media. And later I told some example how applied nonlinear optical phenomena to investigate materials properties, investigate and monitoring processes, preparing different kind of materials. And I told about some remarks regarding composition structure and second harmonic generation intensity. And as finally, I told about my group, international team, investigation of some nonlinear materials utilizing simple spectroscopic methods. I hope it will be quite interesting because a story of nonlinear optics is very strange. I told why. It is a question. Is it possible change color of monochromatic light? It's difficult to do because for example, you can tell, we have color crystals, color grasses, put radiation. It is not good because when we utilizing ordinary light, it is sunlight, for example, we utilizing not monochromatic light, but here is a different phenomena. It is a question. And answer up to 1960, no. But why later? What's happened? In such year was discovered laser. You know what is it, a laser? And laser generating monochromatic light, a coherent light with a very strong intensity. And sometimes many discoveries in physics was discovered not intentional. And here also was a similar situation, because in students' laboratory was performed experiment when people focused by lens ruby laser beam, pass radiation across quartz crystals, and radiation was splitted by prism. And it was a great surprise what happened, because except fundamental radiation, we obtain also radiation with 2 times higher frequency. It was a great surprise, and when authors try to publish article in serious journal, it was a physical review letters, after editor correction, such small dot which present intensity of so-called second harmonic generation was too small, and he considered it as a mistake and removed it. It was a surprise, because efficiency of such process is not so big. Only some percent of fundamental radiation change on second harmonic. And such phenomena was interesting because, as you know, history of physics, it was many, many similar phenomena, like a discovery, for example, high temperature superconductivity. Authors not have idea about superconductivity. They perform ordinary measurements of ceramic utilizing in electric industry. Yes, it is explanation as such information, and as such experiment was discovered in students' laboratory. Sometimes people came to job and play, and as results they obtain very good results of work. And for example, discovery of some recently materials like, for example, graphene. People playing. They came to job in Saturday and Sunday, perform some experiments, except his job, and they utilizing very simple technology, but equipment for application for measurement or detecting was very expensive. It was electron transmission microscope. Okay, what happened when we put a laser beam on a special kind of crystals? Because it's not all crystals generating a second harmonic generation. I thought about it later. When radiation go across crystals, crystals with interaction electromagnetic field with crystals generating a second harmonic. It is a double frequency in compared to fundamental beam. And we have two laser beams with a different frequency, but is also additional remark is important that it is a coherent beam. It is some remarks regarding comparison between optic and nonlinear optic. In traditional optics, some coefficients like refractive index, absorption, are independent of light intensity. The principle of superposition and fundamental tenet of classical optics is holds. The frequency of light cannot be altered by its passage through the medium. Light cannot interact with light. Two beams of light in the same region of linear optical medium can have no effect on each other. It is also important because by light we not controlling another light. Nonlinear optics. It is some difference. Refractive index and consequently speed of light in optical medium change with the light intensity. It is amazing, but it's true. Principle of superposition is violated. Light can alter its frequency as when is passed through nonlinear optical materials. And last is important, but utilizing light, we can controlling light. It is both phonons interact. But it's important that such interaction is across medium, and such medium is very important in phenomena. And from a mathematical point of view, the nonlinearity is usually a very weak effect, and relation between polarization and electromagnetic field can be dividing from linearity and maybe expand as power which is depend of intensity of electric or magnetic field. And here we have some example what we can do. It's also interesting that taking account a very simple equation, we can confirm that nonlinear effects not exist in central symmetry media, second order. Yes, it is in such equation we see that a second harmonic generation not exist, but also appear effects of higher order. And what is also interesting, that second harmonic generation is an effect of interaction light with medium. And when radiation go across crystals, intensity of the fundamental radiation beam decreasing, but intensity of second harmonic increasing. And we have longer distance. Is interesting that one intensity decreasing, but a second increasing. But it is not, it is for ideal materials, because you know that each materials have absorption. It is connected with absorption, that also not all energy of fundamental is moved into second harmonic. And here you in such a picture you see like looking it, but we have radiation from laser, it is a fundamental beam, and is intensity changing, but appear second harmonic with frequency 2 times higher. It is interesting because it is a principle of conservation of energy. Yes, when we generating some phenomena which need energy, energy of generator, the creation. And also is interesting phenomena arise. It is a so-called phase matching, because in materials we have a refractive index which is depend of frequency. And for example, when we split sunlight on prism, we splitting particular frequencies and you see different colors, though non-stable refractive index. And here, what does it mean? What one wave and second broadcasting with different speed. We have two waves with transporting by crystal with different speed. What is what is a result of such? Results of such effect, as we can calculate, is a modulation of radiation, because both waves interact, and we can to see some strange processes. When we have one crystals with, for example, bigger difference between refractive index for both frequencies, we have a modulation of intensity of second harmonic wave. And it is depend between a mismatch between both velocities, and we have some picture of experiment which confirming existing of such phenomena. It is not good for generating second harmonic, but people know some possibilities how obey such disadvantages. What is requirements for crystals as the materials for parametric light generators? And one of them is absence of center of symmetry, and sometimes belonging to some point groups, special groups which give us knowledge that groups are connected with a structure without a center of symmetry. It's necessary to have a large value of a component of quadratic polarizability tensor. It is also important because some materials is more interesting for generating second harmonic, but another have a weak polarizability, quadratic polarizability, and it is caused that they are not so interesting for generating second harmonic. Yes, some crystals with a Sakal Doppler refraction allows to fulfill a phase synchronity condition. And also it is some interesting phenomena. And for example, when we have a laser with a wavelength 1 micrometer, second harmonic generation will be 500 nanometers. When we have a crystals with a band gap with a start, for example, 600 nanometers, second harmonic not be generated because it is absorption, in range of absorption. Therefore, there is some problems to investigate optical properties of, for example, halcogenide crystals. It is crystals which window transparency very often start from 600, 700 nanometers. And when we, in most laboratories, utilizing some laser with fundamental circa 1 micrometer, it is very difficult. We should buy a more expensive laser with wavelengths more 1 micrometers, 1.5 or 2. Also is important parameters. It is resistance to surface and bulk radiation damage. It is so-called high laser damage threshold. It is an important element because, as you know, intensity of second harmonic generation strongly depend of laser power. And when we put a strong laser radiation on crystals, what processes arise? For example, absorption, because it is no media except vacuum which possesses zero absorption. And part of such energy changing on vibration, and it is so-called heat, and sometimes may be destroyed or melt crystals. You see phenomena when laser radiation destroying material. When we have materials with, for example, low coefficient of thermal conductivity, all materials which in useful spectral range possess medium absorption, part of energy exchanging on crystals, and crystals will be destroyed. It is also important, especially for, as I call, Indian science specialties, organometallic crystal, when a temperature of melting is start from 100 centigrade to 200-300 is depend, but it is great advantages because such crystals possess many advantages, like high polaribarability, very wide spectrum of transparency, and such phenomenon may be destroying crystals. Also is some advantages when crystals possess some imperfection, because when crystal possess imperfection, also is scattering inside and generating more heat. It is a many phenomena which coexist with nonlinear optics and is mostly difficult to overwhelm. And I told about such last point. It is high optical quality. And last, when we like transform radiation, we need a quite big size single crystals. I show you that we can perform measurements of nonlinear optical properties material utilizing not single crystals, but for application like transforming when we need, for example, change laser radiation, for example, for medical application and for beauty science, when is necessary to utilizing a special kind of radiation, utilizing special wavelengths to for example, interact with human body when we have illness or imperfection, when we shoot some removing. And we buy one laser and utilizing second harmonic and put shooter, for example, to block fundamental, pass only second harmonic, and utilizing one crystal, we have two laser. One laser is for micrometer, second for 500. Or when we have a ruby laser, we have UV radiation. It is give us some opportunities, but also bigger crystals give adjust angle of radiation on between surface to fulfill matching refractive index problem. Yes. It is also was for a long time opportunities to collaborate with Indian scientists, because with my and my colleague group, we investigate of or working on founding a method of so-called symmetry breaking. It is maybe, for example, for axial pressure. When we put axial pressure, we change, for example, crystal structure in one direction. We can utilizing a so-called pooling. We can, for example, put crystal under interaction with electrical magnetic field, and it is broken so-called centrosymmetry. And now I show you some method which we can do. And from such point of view, also is interesting phenomena, because we have a very sophisticated tool to detecting or monitoring phase transition. When crystal, during heating, cooling, for example, under pressure, like I told yesterday, over structural phase transition, for example, from central symmetry to non-central symmetry, we are able to easy monitoring, because when is another structure, second harmonic generation appear when we go from central symmetry to non-central symmetry structure, and in opposite, when we have a very good signal, a second harmonic, and we go across phase transition to central symmetric, it is appear. It is very easy because it's a non-contact method. We have a crystals, put a laser beam, and we observe what's happened. When, for example, suddenly disappear second harmonic, it is, we have information the structure changing, or laser broken. I think this. Yes, and one of method of broken central symmetry is so-called photo-induced second harmonic generation. We use a radiation of additional laser to induce non-central symmetry, because when we have a medium after under irradiation of electromagnetic beam, it is interact, and such radiation may be modified electronic central symmetry. And here I compare some methods which was utilized for over a problem of central symmetry and adopting some materials, some crystals, central symmetry crystals to generating a second harmonic. We can use, for example, acoustic wave. We can put between plates, like in condensator and capacitor, and we can destroying a central symmetry. When we put crystals in DC magnetic field or AC magnetic field or electric field, we changing central symmetry because some direction is a privilege. Yes, and here is electric DC field induced, magnetization induced second harmonic generation, and second harmonic generation induced by spin currents and by crystal size reduction. You remember yesterday afternoon lecture by Professor Abdul Azam. He told that when we have a big material, big piece of material, it has symmetry, but when we go to nano, we change not only electronic properties like band gap, like another, but also we able to influence on symmetry.
Few members from other than physics.
But it is only problem.
No. Can you correlate
that we will understand.
Please repeat.
So this is completely physics.
Yes.
So we some from mechanical and other department.
Yes.
So we will, in order to understand easily,
Okay. Okay.
some live examples so that we can understand.
Okay, but next examples will be more convenient for the people which not focuses on physics science. Yes. Also interesting, but when we investigate some properties of materials, for example, glasses. Glasses is amorphous materials, not should generate a second harmonic, but we can so-called broken centosymmetry, not permanently during, for example, external field or under radiation, and in such situation we can monitoring some interesting properties of materials, but also, for example, phase transition, because it is strongly influence for behavior of dipole moments, and is from calculation we can understand when we have a phase transition or we have some unexpected behavior, some phenomena which connected with so-called transition in materials, we can monitoring properties of such transition using second harmonic generation. And for example, when we measurement superconductive properties, we can investigate magnetically ordered compounds. Glass transition, it is also important phenomena, and also is important process for monitoring crystallization, because in different application we should obtain, for example, transparent ceramic. We have glass and we like to change glass for glass ceramic. It is a glass ceramic, it is a structure with locally have a crystal structure. And for example, when we utilizing so-called annealing method, because in glass is a special kind of temperature with a called glass transition temperature. And we can describe such temperature utilizing, for example, thermogravimetry. We put a sample to special crucible, and under heating with a special temperature rate, we can see when such temperature is, and is as follow. We put a big sample of glasses in furnace and put radiation. When start crystallization process, we can stop because a second harmonic generation appears. From glass now appears, and we can, for example, monitoring sophistical phenomena in moment when we obtain our needs. Yes, because for example, when we want obtain a transparent ceramics, we not wait to moment when it is untransparent. It will be will be crystallized in a higher level. But as such, give opportunity to see us when a process of decreasing transparency appear. I show just moment. It is example. And next. I promised you information, give information how we can monitoring efficiency of generating second harmonic by different crystals. And in 68, it is after 8 of discovery of nonlinear optics, was not discovered, was prepared a method of measurement second harmonic generation properties utilizing powder samples. And it is good information, but also is bad. I told why. Because, as I told, when we have make a lens, or we have utilizing second harmonic generation for as a tool for transformation, laser radiation, we need a single crystals. But in many laboratories, people able to utilizing very simple method grow nanocrystals. And it is, from practical point of view, is less useful. But we can perform measurements and publish paper that our material possesses very good nonlinear properties. But it is almost unuseful. Yes? And, but such method is connected with in investigation of nonlinear properties, powders with a different grade. And second harmonic generation is depend of particle size. It is a method where we have a powder, put radiation, and in so-called reflection mode, now in transparent mode, we investigate intensity of second harmonic generation. It is also useful method to compare quality of materials, also useful of materials, because, for example, in what is it? For example, here we investigate how efficiency of second harmonic generation depend of composition of crystals, and we perform many measurements, grow a huge number of crystals. In next slides will be it visible. And for example, ternary crystals intensity second harmonic generation is very low in compared to quaternary materials. But also we can apply such method for different materials, but usually method is the same. We have a powder with a different grade and perform SHG measurements in reflected mode. It is a so-called Kurz and Perry method. It will be also continued by in my talk. We also try to predict before synthesis or before start a program crystal grow, whereas such particular crystals possess better nonlinear properties. And here is some results of investigation when we compare the efficiency of second harmonic generation with a band gap of materials. Because we find some correlation, investigate properties several single crystals, which give us opportunity to find a tendency. Yes, when is one of yields of conclusion when the second harmonic generation increase with a decrease the band gap. Because when we grow single crystals, we sometimes try to grow a series of crystals with a modification, cationic pair, anionic pair, make a solid solution, but sometimes it's very easy utilizing, for example, quantum chemistry calculation, describe a structure and confirm it is material central symmetry or non-central symmetry, and calculate band gap. Maybe calculation is not advantages of quantum chemistry calculation, but we are able to see a trend. And here give us some information regarding which crystals should be a better nonlinear optical properties. And here is such practical, in practice, experiment was done by Japanese people, which observe a crystallization process. And it was interesting because they have in furnace materials and put and irradiate by laser. When second harmonic generation appears, doesn't mind when a crystallization process starts. It is a very good tool for investigate properties, materials during a process of preparation when we have a non-contact method. We put radiation on surface and, for example, we use microscopes, we start be green, we know that of crystallization start. It is very good, important for monitoring preparation of materials, especially for industry. Now, transparent ceramics is a great challenge for science.